Human Tech, a podcast about the intersection between humans and technology. My name is Guthrie. I'm here with Susan. Hello, Susan.
Hey Guthrie, how are you today?
I'm doing well. Today's topic is about process architecture and some of the changes that are coming up and how that sort of interacts with specific UI.
Process architecture. Fancy term. How
Uh,
process architecture changes are going to intersect with user interface. Okay, you're going to have to explain what you mean by that. But go ahead. I'm
yeah.
ready.
Okay.
Maybe.
No, we got this.
Okay.
So, in some ways, this is a new problem, and in other ways, it's not new at all, and it's an ancient problem that has been around for a long
For
time,
thousands of years?
thousands of years. So, some people out there may or may not know I'm really into computer hardware, less into computer software, but really into computer hardware. And I follow all of the trends and process nodes. So, process node is the family of technology that various companies use to create chips that everything runs on. So, this would be
We're
uh,
getting very nerdy here.
yeah, right. You have the Intel CPU, you have your NVIDIA graphics card, you have your AMD,
And you,
CPU.
you keep up on all that.
Oh yeah. So right now, I've talked in the past about stagnation in Moore's law. I mentioned it a couple of years ago. I'm sure everyone remembers that. But
No, they don't.
but yeah, so there was a stagnation. For those of you who do not know, making chips is a very difficult, very expensive, bleeding edge process. And there are just, at least for the, cutting edge, there are not very many players in the space, hardly any in the entire world. So, um, one of the reasons why you want bleeding edge nodes is that the smaller you can make the little component chip, it means you can fit more of them in a single size. You can reduce the power that it uses. There are all sorts of benefits to having a smaller node. Generally, the newer slash smaller the node, the more you can, the better your chips are relative to other designs on previous generations.
Okay.
Now, so there is, of course, an advantage of having the best node, and the company that probably does the best job of this is Apple. They don't own, they don't make any chips. They design their own chips, but they actually are not creating anything out of silicon. But what they do have is they have incredible size and scale. And so when the new, node capacity becomes available, they are front of the line. They get to book their stuff before anyone else, and they get like 8 months of just crushing it and amazing performance. The best example is often with their with all their chips, with their mobile chips, and with now their what's now M1, their desktop custom designs. The custom designs are very good, but it's unlocked because they're using new node tech that no one else has right now. And in a couple months or in a year, it will, the competitors will show up.
Everybody will
So
catch up. Okay.
yeah, so there really is a competitive advantage. There was a period of stagnation, and it was in the space. It was sort of a running joke. There are only a couple companies that actually make chips. Beyond, there's some like weirdo ones in China or something. I'm gonna skip those. But there is Intel, probably the biggest chip manufacturer in the world, and they make a bajillion gazillion chips. Chips you wouldn't even imagine that they make. They make all kinds of stuff. We of course are familiar with the cutting edge, CPUs that they use, but they make all kinds of stuff. And then there is the second biggest player is TSMC, which is a Taiwanese company, and they potentially are, over the last decade, they've established themselves as maybe the most with it, the best chip fab maker in the entire world. Everyone uses TSMC. Everyone wants to get on TSMC. Even Intel uses TSMC for their new graphics cards. Their nodes are just really good right now. Apple uses them. NVIDIA uses them. AMD uses them exclusively, I think, for their current generations. So that's TSMC. Samsung has nodes. They make Samsung. There's also a sort of a sister technology, which is the companies that make stuff for like RAM, like memory modules and stuff. That's a little different. But yeah, Samsung has a node, and it has the most recent node has not been great, but they have their own fabs. So if you get a Samsung phone, the international versions are used made. They have their own fab. And then there's Global Foundries. They used to be a big player, but they were like, we can't compete. We're with TSMC. We're just out. So I think they're still puttering around, and they have older, bigger nodes, because you still need the old nodes to do stuff like chips for cars or calculators or
Toasters or something.
refrigerator. Yeah, you listen the older nodes, they're still useful, but you don't need them on you don't need the cutting edge. And then there's other smaller, Texas Instruments, I think, is still
You are going to get to where this intersects with UX or UI, right?
Yeah.
Okay, just asking.
So the last there was a period of time where a lot of progress stalled
on the whole chip front.
The chip front, and it's because there are these certain, so Moore's law, right? Which is
so what is Moore's law? I know we talked about this a long time ago on one of our podcasts, but let's review.
Moore's law. There was I believe it was Intel's founder, Mr. Moore.
Seriously? All right, now we have to go look this up. And I'm sure I asked the same question when we first talked about this.
Or is it Robert Moore?
Looking up Moore's law.
Moore.
Okay, Gordon Moore.
Gordon. Yes.
Okay, Gordon Moore. While working at Fairchild Semiconductor, supposedly, he then went on to co-found Intel.
Yeah. So this is
like in 1965.
I don't think people realize how fundamental Intel is to like semiconductor manufacturing. Like they basically invented everything.
So
like everything. So the only people who make CPUs are Intel and AMD. AMD used to be an Intel brand. Like the only reason it exists was because of antitrust, and Intel had to spin them off, so they had a competitor.
So so interestingly, everything we're doing on computers, we pretty much owe to Gordon Moore, and nobody knows his name.
It's amazing. So even all the processors, there's the x86 processor, like process instructions, that we use, and that's how all the computer code runs, like in the entire world, is on x86 processors. There's some really weird stuff in supercomputers, but basically it's all the x86 instruction set, and it's called x86 because of like the 8086, which was the Intel processor.
I remember that.
70s and 80s. So it's like that is like the every single computer in the entire world. It's like its evolutionary ancestor was this Intel 8086 processor.
All right,
it's really crazy influential.
This is the according to some website that I'm looking at. You can tell me if you think this is accurate. That Moore's law is a term used to refer to the observation made by Gordon Moore in 1965.
A long time ago.
That the number of transistors in a dense integrated circuit doubles about every 2 years. Is that what you know of as Moore's law? Is that accurate?
The transistors has sort of fallen by the wayside.
That was the term in 1965.
Yes, but you can just say elements.
I had a transistor radio. I remember when
Sure.
transistor is that term used anymore? Do you know what a transistor radio is?
Well, I do. All radios probably still transistor radios. They're just called radios now.
But they didn't used to be.
Because so they used to have vacuum tubes.
Right. They
Right.
used to have
And
vacuum
transistor, I mean,
tubes.
all computers used to have vacuum tubes. Before they
And
invented the
right.
transistor,
And so
you had to use a vacuum tube.
the big thing, and these were coming out of Japan, and when would this have been? Sometimes in the 60s. That now, because when you had radio, I know I'm taking a digression.
Uh-huh.
Please,
Right.
you can just be patient or not. Um, Radios used to have the vacuum tubes, which are big and heavy, which meant radios were big and heavy. So they were a piece of furniture. And then it got to the point where they were maybe as big as a bread box, if anybody knows what that means.
So
Um,
for those, well, just quickly, for those of you who do not know, a vacuum tube is literally, that's like a light bulb, because light bulbs actually, the old style incandescent light bulbs,
yeah,
they're a piece of glass. There's a vacuum inside that
inside,
glass,
right.
and then there's the filament.
But
And so a
vacuum
vacuum
tubes,
tube,
yeah.
it's a piece of glass that looks like a kind of like a bulb, and there's a vacuum on the inside
And
that was
all
filled
kinds of
with something.
stuff had vacuum tubes, and radios had vacuum tubes, and they're big. And so the radios were big and heavy. Like I said, initially they were a piece of furniture, and then they got to a tabletop variety. And then instead of vacuum tubes, the Japanese, at least that was my understanding, came out with transistor radios, radios made with transistors rather than vacuum tubes, which meant you had radios that were like this big. And that was just amazing. You could bring, because I remember I lived in New Jersey at the time, and we used to go, I was a kid, and we used to go to the Jersey Shore, and all of a sudden now, everyone was playing the radio at the shore on their little transistor radios. And that was so cool that you could take a radio with you anywhere you went. That was like mind boggling. Okay, yeah, that's sad. I'm really old. All right, now, where the heck were we? So you were talking about Moore's Law and you were talking about stagnation.
So Moore's law has, done a pretty good job, but sometimes there are these, I guess, sticky points. There are these cliffs in
Where
Moore's law where things get
where
stuck.
things don't progress in a 2-year
It's
cycle.
it's incredibly complicated, and the smaller you do everything, the more expensive and the more complicated it is, and
All
that's
right, so
why.
when was the last stagnation?
So the last stagnation started around 2012.
Okay, 2012.
And I remember because I built a computer at that time
Yeah.
using the Sandy Bridge, I believe a Sandy Bridge Intel processors,
Okay.
2500K.
Okay.
That was the chip, and it was like a really awesome chip. And basically, things were started to slow down about that time,
Yeah.
and a couple years later, there was like the 6500K.
Yeah.
Okay, so that's what, 4 generations. So that's 4 or 5 years later.
Yeah.
Intel usually comes out with new chips kind of every year, so it doesn't. Sometimes it's 18 months. Anyways, there was sort of a running joke because Intel, um, for the longest time, they had what's called the tick-tock strategy. So the way it worked is basically one generation you focus on making architecture improvements to the chip, so changing the way that everything's laid out, and okay, here's a new design and that kind of thing. And
Yeah.
then the second iteration of that is you just take that design and you put it on a smaller node and you shrink it,
Okay.
which means it's more power efficient and you
Okay.
can run it faster and better. So
Right.
so basically, so then you're alternating
Right.
cycles.
Okay.
So that was the tick tock, and that's what they, kind of, that was the cadence for a really long time, where you change the chip and then you shrink it, and then you change the chip and then you shrink it.
Yeah.
And they got stuck
In
on
which cycle, the tick or the tock?
on the shrinking, and
Okay.
so there was 14
What do you mean
nanometer.
they got shrunk? They got
They get
stuck.
stuck. Okay,
Do you
so
mean that they kept shrinking without the redesign, or do you mean they couldn't shrink?
couldn't shrink.
Okay. So they
Now,
had the design and they couldn't shrink.
yeah, now it's a little more complicated because just because you kind of couldn't shrink, there's still you can perfect a certain node. You know, you can make
Yeah,
things better even if you
right.
don't
Even
have
if
new
you
tech.
can't
But
shrink.
you're
Okay.
so it's not like the chips weren't getting better, but it wasn't
But
as
it was
dramatic.
kind of like the stagnation because they weren't changing.
Right, right.
Okay.
And so just to give you a sense of things, okay? So in 1990 there was a node shrink,
Okay.
okay? Then there was one in 93.
Okay.
Uh sorry. Actually, no, I'm gonna skip that. It doesn't matter. Um so basically uh right around that time,
Which time?
that
2012?
2012 is to 2014,
Yeah.
okay?
Okay.
Um they just they just like ran out. So then there was like so it was the 14 nanometer node, and then there was like 14 nanometer plus,
Yeah.
and then there was like nanometer plus plus,
Yeah. So
and then
nothing
there
was
was like
happening.
14 nanometer plus plus plus.
All
It
right.
was
So
sort of like
how
a
long
running
did
joke.
this go on?
um
When did things get unstagnated?
so yeah, I just want to make sure I'm doing it right here. um so I believe, yeah, there was Ivy Bridge. That was, I mean, it wasn't just that node. It was the kind of the ones before it. Like the ones before it kind of were like slowing down, and then
Okay.
it just sort of hit a standstill. So as far as I can tell, um, yeah. So it wasn't Haswell. Yeah, it was basically Broadwell. So Broadwell was the 14 nanometer, and that was 2014. Okay.
Okay.
So then there was Skylake, which is also um, the big one. So 2014. So then 2015, it was the same, and then it was Kaby Lake, which is 2016, also the same, and then it was Coffee Lake, which was also 14 nanometer, which is 2017. So like they were just stuck
For several years.
for several years, and they kind of start there were they kind of started to do some shrink, and there was some benefits, but basically for regular old computer chips,
So did
they
they
would
ever
start
get unstuck?
they are now
Unstuck.
unstuck, and
Okay.
the reason is because of a process called EUV,
Okay.
um, which is there's in order to make to carve the very small parts in these
Yeah.
dyes, there's not a physical device. You use wavelengths of light to do it.
Wow.
Yeah.
Really?
Yes. And that's how small these things are. And
Wow.
so EUV stands for extreme ultraviolet.
Wow.
And so basically, if you think about wavelength, right? You know that red is like the bigger
The big long
waves, long waves, and
and
it's just because it's bigger, you can't make things as small. And so when you have like ultraviolet, it's a
it's the
much
tiny, tiny,
tiny
tiny.
thing. So your wavelengths of light are smaller, and so you can make smaller components. This is difficult to do, and there's basically one company on Earth that makes all of the chips the chips for lithography or all the machines that can do this kind of work,
Yeah.
and it just took a lot of years for
To
them
put them
to
together.
put it
So
together. So finally,
we're back on a
well,
non-stagnation.
now everyone has most of the fabs have transitioned to EUV, and we're on the other side.
Okay.
And it's not like these guys have been doing nothing.
Right.
They've been
But
they've
they
been busy.
haven't had a big switch in
Well,
a
they've
while.
been waiting, right? They've been so now that they're through to the other side, now it's going to happen really quick.
Okay, I'm going to press you. What
Yeah.
does this have to do with UI and UX?
So, do you remember in like the late 90s, early 2000s,
Yeah.
when there were huge jumps in computing power?
Yes, I do.
And so, suddenly, you go from Windows, 1 to Windows 95 to Windows
Well,
XP.
yes. Although I could possibly back you up even earlier than that and talk about what I assume, but I'm just assuming that there were these tech and chip advances that allowed us to create what were then called personal computers, PCs, meaning, because there was a time when a computer was a gigantic device that was in a big room in a building all by itself. And then what I think is funny is that we had mainframe computers, and then we had mini computers. We eventually got to mini computers. Mini computers would only take up a small room, you know. I mean, mini did not mean mini, but that's what, Um, and then we got to PCs, personal computers, and that would have been in the mid to late 80s. And it was the first time that regular people could use computers. So I remember that transition, which I assume was also very much a chip and hardware transition.
Yeah, I think that is going to be different because
That's going to be different. Yeah.
paradigm shift. We're
Yes.
talking about it's not just like it's a different class of hardware. It's like we've gone from a horse to a
Yeah.
combustion engine.
Okay. All right. But if you're talking about the late 90s and early 2000s, yeah, I remember, because this is when I mean, from a UI UX perspective, this is when we shifted, for instance, to graphical user interfaces in a big way. This is when we shifted to much, much different quality of monitors and
Right.
visual
And
processing.
that's why I
And
think like XP is maybe like the bigger shift, right? Because before then
yes,
it was a graphical user interface, but it was
yeah,
flat, it was two-dimensional, there were no fancy animations, and all of
nope,
a sudden you unlocked this
right.
performance, and there were
And you
things
went to
that
a different,
popped
right.
up, and there were all kinds of animations and programs, and everything
Yes.
was HD, and
Yeah.
it was
That
different
was a big change. Yep.
because um, likely in the next 4 years it is entirely possible that we will see a 4x in computer processing power on
So
regular
you think
desktop
what? All
machines
right. So you think
on the
that
graphics
from
side.
the early 2000s to now, which is a long time, we have made incremental improvements in terms of the visual.
2010s, not the early 2000s, 2010s.
Okay, from the 2010s. Well, okay. I but I'm going to argue with you here, okay?
That's fine. You can argue.
I'm going to argue with you that that the changes from a UI UX visual perspective were quite big in the early 2000s, and that since then, in terms of these visual aspects, animation, UI UX, there have been changes and improvements all along, but they haven't been sudden, except in mobile devices. And
Right.
that was a huge, that's huge, right? We
Well,
had,
where's the bottleneck, right? And in mobile, you have tons of bottlenecks.
yeah. And to me, if you're talking again about UI, UX, visual animation, the huge changes in in the in like from 2008 and so on, we're in mobile. But what you're saying, and otherwise, I think it's kind of been my memory, and I could be wrong, is that it's been incremental. But regardless, you're saying that we are possibly on another edge here of a big change. And the question is, if we are on the edge of a big change in terms of processing power, in terms of visual rendering, in terms of um, animation, what's the impact that may have or could have on the UI slash user interface slash user experience of
So,
stuff?
so let me ask you a question.
Yeah.
Why don't our applications today look like Windows 95?
Well, some of them do.
No, but like modern, modern cutting edge stuff,
Well, okay, why don't they? Some of
right?
it,
It's like
some of
whatever
it has
horsepower we have,
the
developers are like, we
horsepower.
gotta use it.
Yes, although some of it has to do with trends. It's like fashion. It's like clothing.
It is.
Like, oh, uh, the waistband of the pants is supposed to be halfway up your chest. No, it's not. It's supposed to be below your navel. Or the 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 width of the pants at the bottom by your feet is supposed to be really tight. No, it's supposed to be a big bell. I mean,
Well, let
these
me give
things
you an
kind of
example.
pendulum
Let me
shifts.
give you an example.
Yeah.
And so, if you remember the Windows Vista days,
Yes, I do.
and people did not like Vista, and that was a
No,
problem for
Vista
different
was not
reasons.
a yeah.
The One of the big things that Vista and then into Windows 7 did unlock was that in XP it was three-dimensional and there were animations, but it didn't necessarily have a scheme for fancier animations. And what Vista and Windows 7 unlocked was transparency. So you could have like one window, like when you move it, it would like become transparent and you could sort of see
Yes.
underneath it. And so all sorts of programs and stuff started doing, because you couldn't do that before because there wasn't the
Yes.
computing power to calculate, multiple visual things at the same time. And so all of a sudden these fancy animations that before were not possible, it was possible. And so they did them, regardless of not if it was perhaps a good idea.
Okay. Now, all right. Now you did it. Now you pushed the buttons.
Yeah.
Now I'm going to lodge a complaint.
Yeah, sure.
I have a complaint. So my complaint is that what's been going on for the last, and I wish I could think, I don't know that I've thought this through enough to know how long a time period we're talking about. 5 years? 10 years? Probably more like 5. And it's so interesting that you brought this up, Guthrie, because I think there are these changes that happen that I don't know. Maybe it's just because we're so busy. I don't sit around and think about these things. But I think there are changes that happen that you don't realize what's been happening until someone asks you a question and you look back and you go, wait, what's happening? All right, here's my complaint. My complaint is, what does UI mean? What does it mean to design a user interface? What does it mean when we talk about UX design? And where has that gone? I think UI and UX is wandering off into this place that it didn't used to be. And I think some of us, like me, have not been paying attention. And then I think it's caused a big and very important gap. So, based on what you're saying, I think all of these visuals and all of this animation and all this transparency things and everything else that's
Shaders,
going,
sliders, videos that play in
all of
Windows.
these things that are now available to do that we didn't used to be able to do, so nobody was doing them. They're all being done now. And for some reason, instead of, and honestly, anyone can call in or write in or interrupt us if you don't agree. I think instead of that whole field necessarily having its own specialty, it has taken over what the term user interface. And to me, old school me, to those of us who've been designing user interfaces for decades, that's not what a user interface is. But I think that if you say, oh yeah, we got to design the user interface, I think now for a lot of people, they are referring to this. They're referring to visual design, they're referring to animation, they're referring to all of that. And that's okay, I guess. But there's this piece of design work that now is getting lost that I think is, of course, I'm going to say this because I've been around for too long and I'm old school, but I think there's a part of what I thought was interface design, or maybe you want to call it UX design, that it's like a lost art. It's like nobody's doing it. So, you and I have talked a lot about the fact that UX research and user research has grown unbelievably. And, a not insignificant part of our business now is finding good UX researchers to help us with our projects we're doing for clients, and clients want them as contractors and clients want them as permanent hires. It's like this growth thing. And now there's like this, if you talk about, UX research versus UX design, what the heck is UX design? I don't think it's clear anymore. I read an article recently which said it's dead, that UX design is dead, and that it's all turned into user interface design and visual design and animation design. But there's this piece, in between all the research you do, and before you start creating screens and pages and whatever, there's this piece of design that I'm just going to call conceptual model design, because I don't know what else to call it these days. That is anybody doing it anymore? I don't think anybody's doing it anymore. And it's like the most important part of design. So my complaint is that with all of these new capabilities in the hardware that you've been describing, which leads to all these new capabilities in software, that everybody's getting focused on that, and we're losing this critical piece of UX design. There you go. I've said my piece.
Well, it hasn't. My point is, it hasn't started yet. So
no, it's already started. So you're telling me if I thought it was bad before,
the first
really going to get bad.
Jump.
Yeah.
Okay.
Yeah.
There's going to be like 4 big jumps, like one after the other after the other.
Yeah.
The first big jump is happening right now. A couple months ago, Intel's new CPUs, that was a big jump. And in a couple months, AMD will have a big jump. And a couple months after that, both AMD and NVIDIA will have new graphics cards, and Intel will have new graphics cards that are big jumps. So in the next 12 months will be the first big jump. And by big jump, we're talking, 80% increase in CPU performance,
wow,
80% increase in graphics performance for the price.
All right.
So in the next 12 months, big jump. And then after that, another big jump. And after that, in a year, another. So these big jumps are going to be coming that will, again, almost every generation, every 2 years, doubling performance, 18 months, doubling performance. So it's going to, a top of the line computer as of last year will have 1/4 the performance of, a regular computer in a couple of years. It's going to be really wild. And there have been times in my life when that has happened. I've lived through those. You obviously have as well. But it hasn't happened in a while. And I think we just kind of forgot oh my God, you can do this on a device this small.
All right. So all right. So from a UX behavioral design perspective.
Right. There's suddenly going to be all this
So
horsepower.
what are we going to how should we and other people listening who are in this field, how should we think about this? How should we prepare for this? What do we do? Any answers? Okay, now, Guthrie, you have frozen. So I don't even know if you can hear me. All of a sudden, I guess the question I asked was so difficult that it overwhelmed. It's kind of funny that we're talking about changes in power and chip design, and then his computer freezes. So I'm just going to keep talking and hope that he comes back. So I'm thinking, and I don't know if Guthrie's going to agree with me or not, that we need, I hate to further segment things, but maybe we need to. Maybe we need to really get serious about, it's interesting. Do we as UX people and user interface people, do we want to let more and more of this go and become not UX infused and not part of UX? Do we say, okay, yeah, hi Guthrie. I kept talking while you were gone. So how do we prepare for this? Do we just let more and more of UX and UI things that we used to think of as being UX UI, do we let go of them? Let that become design. Let that become technical. Hope we can figure out a way to influence it, but just let there be specialties that are doing that stuff, and that's not what we do. Or do we hang on to it and say, no, these things, these animations, these capabilities, this motion you're building in, these visual changes, they are integral with what's called the user experience. We will not let it go. We're going to hang on to it. This is still part of what it means to do UX.
Can you hear me?
Yeah.
I'm back.
I know. Did you hear what I just said?
Yes, I was just making sure. I didn't want to.
Yeah, I can hear you.
So
how do we deal with this from a UX?
To my mobile hotspot.
How do we deal with this from a UX behavioral design point of view?
If anyone can tell me why my internet goes bad at like 1 p.m. and that's the only time.
You are off topic.
Well, I think there is a difference. I think it will depend on the application, because there are some applications, because the new stuff is coming now, right? So if you look at applications that need to run on a wide range of computer hardware, they're still going to be limited by previous machines, and I don't think you'll see a whole lot of changes there.
So you're talking about the new stuff.
Yeah. So if you think of like a website for some healthcare company or something, right? All sorts of people on all sorts of devices, including low-level ones, will have to use it. And so that will remain conservative.
But if you're doing new product design.
Well, that's exactly right. So if you're doing new stuff, if you're doing, video game things, if you're doing, stuff
things, but if it's, new and it's supposed to run on,
or maybe it's like you detect the device, and if it's a newer device, you use the new version.
Yeah. Because you want to be competitive. You want to be doing the newest.
Think of how flashy things could be.
Okay, but
crazy high textures, resolution.
All right.
snazzy
you know, I
animations.
know, but here you see, this is the analogy. This is the, this is, every time there is a big switch in, in especially visual capability,
Right.
um, typically what happens is, everyone goes crazy and they do all this stuff, and then eventually somebody says, I don't know that this is very usable, and then all of a sudden the human factors, usability, user experience part of it comes into play. That's you, at least that's been the history. But I get the feeling that, and so there's this time period where everyone is enamored with the new capability, regardless of whether it's useful or usable or not. But I also feel as we march into the future, that question about usefulness and usability becomes quaint, and nobody wants to hear about it, um, and and it gets ignored. So and that's why I think, this question of, is UX design, you know, still viable or is it dead? Is I don't know. I'm very concerned. I'm very concerned about this. So, like I said, my question is, do we let go of this and just let the technology and the possible design stuff, just let that group have it and see what they do? And then we're involved in the research phase, and we're involved in the evaluation phase afterwards, when it's a big mess and we can let everybody know it's a big mess, but nobody's going to change it. I don't know. I'm worried about this. I am worried
So
about
I
this.
mean, right now, not a lot of people use 4K monitors.
Yeah.
Um, a lot of people use 4K televisions, but
Yeah.
when it comes to monitors, most people are on 1080p still, or even 1440p.
Yeah.
And once you sort of hit that magical threshold, right, where 50% of people are on 4K monitors, right? It's like, all right, now we're going to design for 4K
Yeah.
screen resolutions.
Yeah. Yeah. Yeah.
And
I
that
know.
means that you can cram a lot more visual stuff because it'll be so much clearer, right? It's the same as if you took, a normal monitor and just sort of stretched it, but it's the same clarity. So you could have all sorts of, so I was just looking at an app right now, right? And they have room for a couple badges, a couple things, a thing here, a thing there. Whereas like in the future, maybe there are modules all over the place and it gets busier. And there's, you can put a lot more stuff because the textures are higher resolution and everything's cooking at, 4K or something. So these are the busyness
All
of it.
right. All right. I have a question for you. So
Yeah.
let's say you get a phone call from one of our clients.
Mhm.
Well, you probably wouldn't get a phone call anymore. Let's say you get a message from one of our clients.
Mhm.
And the question they have for you is, what should we do about what should we do to prepare to be active in the UX UI of this new technology? What would you say?
I have no idea.
Well, that's exactly how a consultant should answer. I have no idea.
I
Yeah,
don't.
I don't either. I don't either. But Guthrie, now you got me all worried. You got me all worried about this. I
Yeah,
don't I
maybe.
don't know if you're, yeah. I mean, I think the other problem is, if you're like, if you're studying to be a UX designer right now, how do you prepare for this? How do you, you know probably you can't. Probably you can't, because it's not like you can learn how to design in this at the moment, because it doesn't exist. Yeah. No, this is problematic. Thank you, Guthrie, for complicating my life. I really appreciate it. But I'm going to think about this some more. And think about where what is the role of UX in all this. That's what I'm going to think about moving forward. All right, we have just about used up our time, as we usually do, and Guthrie continues to have, unfortunately, technology challenges. So I'm going to kind of see if I can take us out, since he usually does that, and he's not here at the moment. So if you have questions or comments on our work, if you have suggestions for future podcast episodes, please contact us. You can reach us. The best email to use is info@theteamw.com. And we love to hear from people. So go ahead and let us know. And in case you don't know, we do these live streams once a week, usually at noon Central Time in the US time zone. And they stream live on LinkedIn and also on YouTube. And then is also available as an audio podcast at Human Tech as the name of the podcast. So that's what we have for you guys today. And thank you so much for listening, and have a great rest of your day.